This lesson is IB 19A. So this chapter is on applications of integration, and there are only 4 sections. And this first one is the area under a curve. Seems to me like we've already talked about this in chapter 18. And so let's recall that if you have a curve, f of x, on a closed interval a to b, and as long as if f of x is positive or greater than 0 on the closed interval a to b, then the area under the curve, which means the area of this region, is so area from a to b, it'll be the integral from a to b of f of x dx. And then likewise, whoops, I should have made it down here. If it's negative, like say your function's down here, let's call it g. If the function is negative on the entire closed interval, then the area would be the opposite. Since that integral would be negative and you want your area to be positive, you'd have to negate it. So in this case, whoops, that's supposed to be a to b. Blah. Okay, a to b, it'd be negative if g of x is less than 0 on the closed interval a to b. So we can jump right into some examples. Example 1. Find the area of the region enclosed by the line y equals 2x, the x-axis, and the lines x equals 0 and x equals 4. So that's their way of saying the front on the closed interval 0 to 4. And we're going to do this 2 ways, with geometry and with integration. So make sure you go to the trouble of doing it with geometry so you get that practice. And also with integration, you just want to be good at both techniques. So up here I'll use the space to graph the line. Or y-intercept at 0, slope of 2, up 2 over 1, up 2 over 1. I am going all the way to 4. So, well, 4 is going to be 8. 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5, 6, 7, 8. We know 4 is going to be 8. 3 will be 6. There's y equals 2x. I'm drawing a nice picture because I'm going to have to use geometry, so I need a good, accurate drawing. And then the line x equals 0, so that's here, and then x equals 4. There we go. So it's a triangular region, perfectly triangular, so the area would be 1/2, the base, which is 4, the height, which is 8. Half of 4 is 2, 2 times 8 is 16 units squared. Then the second technique is using integration, so we're going to integrate. We have the function is positive on the entire interval from 0 to 4, and our function is 2x dx, so this is very nice to integrate. That's going to be x squared from 0 to 4. Plug 4 in, we get 16 minus 0, so 16 units squared. Nice and easy. Example 2. This is going to be a nice short section. Find the area of the region enclosed by y equals x squared plus 1, the x-axis, and on the closed interval from 1 to 2, because it says from x equals 1 to x equals 2. Well, we should draw a picture just to make sure that we can proceed with our integration. So x squared plus 1, that's a parabola that is translated up 1 unit. It's going to open up. And here's 1 and here's 2. So we're looking for this area right here. Sure enough, it's positive, so we can just go from 1 to 2 of x squared plus 1 dx. Integrate, that's x cubed over 3 plus x from 1 to 2. 2 cubed over 3 plus 2 minus, plugging 1 in, so put those parentheses, 1/3 plus 1. And to be honest, the way I would do this, I wouldn't even combine these fractions right here. I would just write 8/3, let's do plus 2, minus 1/3, minus 1. And then I would do my 8/3 minus my 1/3, and get 7/3. 2 minus 1 is 1. And then it's easy enough to do that. It's 3/3. 3/3 plus 7/3 is 10/3. And this is area, so it's units cubed. Now you can also check this on the calculator, which we have talked about. I'll just do it again. I'm going to do it that new way on the graph, which I think is kind of fun. When you do it with the graph, you just put in the original function, x squared plus 1, zoom 6. And then I am going to go to second trace. This thing looks blurry to me. And it's option 7. Lower limit is 1, upper limit 2. Oops, see, that doesn't seem too right. I forgot to hit enter. Here, just hold on a sec, delete. Okay, 1, and then upper limit 2, enter. And it's 3 1/3. And it shows the little area. And the last example is more of the same, it's just a trig example. Find the area enclosed by one arch of the curve y equals, whoops, that's supposed to be sine 2x. And the x-axis. So the area under one arch of this. Let's practice graphing this by hand, since it is something you need to know how to do. So the 2 here affects the period, and one way of doing this is to actually just find the period. The period is 2 pi over b. Well, b is that 2. So 2 pi over 2 is, of course, pi. So that means sine has to complete one entire cycle over a distance of x equals pi. So from 0 to pi, it has, of course it starts here, it has to go up, it's going to go up and down and back to pi. So at pi over 2 is where it's the halfway point. And so sine looks like that. So this would be sine of 2x. And we are finding the area under one arch, so we're going to be finding this area here. That's a positive, so it's just going to be integral from 0 to pi over 2 sine of 2x dx. And then the integral of this is cosine. Actually, it's negative cosine, silly me. Because the derivative of cosine is negative sine, and so we have to negate that. And also you have to divide by that 2. It's like the chain rule. And then from 0 to pi over 2. Let's also do this by hand. So you're going to have, I'm going to pull out the negative 1/2. That's just one way of doing it. And so I've got so what I'm doing here is I'm doing this. So I'm just going to set the negative 1/2 outside. And then I'm going to, here, I'll come down here because this is the one I'm really working off of. Do a big thing like that. So I'm doing cosine of 2 times pi over 2 minus cosine of 2 times 0. Just to show the work of what I'm doing here. So let's come, I'll change colors so you can see where I'm at here. I'm going to come over here. Negative 1/2, bringing that along. So I'm going to have the cosine of pi, and that's going to be negative 1. And then I've got the cosine of 0, which is 1. So it's actually minus cosine of 0. So that's negative 1/2 times negative 2, so therefore the area is positive 1 units squared. Let's check it on our calculators. Let's use the other technique that you can use on your calculator, which is fint. So that's on a blank screen. Math 9. And my function was sine of 2x, right? Sine, this thing should be defaulted to radian mode. Comma x, comma 0, comma pi over 2, divided by 2, enter, 1. So that confirms what we just did. There is an investigation in this section that we can do in class. This concludes 19A.